Okay, everybody, let's take a look at 4 review problems. Give these a try, pause the video, and then let's go over them. All right, you think you have some answers? Let's take a look. For this first problem, we want to know which of these sets of ionic substances will produce basic salts. Well, calcium ions don't affect the pH of anything, and sodium ions don't. They're the conjugates of sodium and calcium hydroxide. But calcium carbonate, the carbonate affects the pH, and the phosphate affects the pH. Both of those form basic solutions. So that one seems like it could work. But let's take a look at the others. Neither sodium nor bromide affect the pH at all, so we can get rid of that one. Iron 3 chloride. Iron chloride, the iron actually produces an acidic solution. Calcium carbonate would produce a base. So we can cross those answers off. Sodium phosphate, the phosphate produces a basic solution, just like we want. But bromide doesn't affect the pH. And ammonium is the conjugate acid of ammonia, and it will make it acidic. Now let's take a look a little bit at why iron seems to change the pH. Group 1 and Group 2 cations are the conjugates of strong bases. They tend not to affect the pH of ions. But other cations, especially highly charged transition metal ions, strongly attract electrons. They so strongly attract the electrons that these electrons right here, the ones in the red bond, are more attracted to the iron, oops, lost some electrons, than they are to the hydrogen, leaving the hydrogen ion to float away and find some water, forming hydronium ion. So it turns out that strongly charged cations produce acidic solutions. Aluminum nitrate or chloride is pretty acidic. Iron 3, pretty acidic. Zinc ions can produce acidic solutions. All right, let's take a look at the next one. The next one, I have a strong acid. So if I know that that has to go first, I can cross off those two. I have a weak acid, higher pH, same concentration. I have a neutral ionic compound. Hypochlorite is a basic anion. Potassium doesn't affect the pH. And potassium hydroxide is a strong base. Third one, I have the pH, and I want to know the Kb. This is not the same as I have the Ka, can I find the Kb? This is, can I do a Rice problem to calculate the Kb? If I know the POH, I know the hydroxide ion concentration. If I start my Rice problem, hypochlorite, so when the hypochlorite reacts with water, the hypochlorite is a proton acceptor. It grabs the proton, leaving hydroxide behind. If we see this Rice problem, well, now I need a Ka to find X, except I don't, because I know the hydroxide ion concentration. If I know the hydroxide ion concentration, I also know the HClO concentration. My Ka is hydroxide times HClO over ClO minus. Sorry, my Kb. So the correct answer is 3.7 times 10 to the negative 7th. And let's take a look at the last one. I need to figure out the equilibrium constant by adding and subtracting these reactions. If I add HF, the first reaction, and the second reaction together, I get HF and NH3 and 2 waters form fluoride, ammonium ion, hydronium ion, and hydroxide ion. If I then flip the last equation and add it to the sum of the previous two, I end up with the equation at the top. That means I take my Ka multiplied by my Kb, because when we add equations, we multiply equilibrium constants. And because I flipped the last equation, I divide by Kw. That gives me an answer of B. Okay, any questions? If you have some, let me know, and we'll work through them when I get back.